Hey, so in the previous video, we determined whether or not certain functions were conservative. In this video, we're going to use conservative functions to do our integral. Okay. Okay, so the question is number 12. It says find f such that f equals a gradient of f, and then compute this right here. Now obviously, how are these two related? Well, if it's conservative, I can replace that with del f, obviously. Okay, so I want to find the a function f such that del f is equal to this. So first thing you might ask yourself is this even conservative? Let's check real quick. So the derivative of p with respect to y, this is going to give me 4xy, and if I take the derivative of the second one with respect to x, I get that. So hey, indeed they are equal, so this is conservative. Conservative. Okay. Now, this is an interesting thing I'm going to do here. So, suppose that, well, we don't have to suppose, we now know these are equal. So, I have this. So, what does this mean? It means that del f by del x is equal to p, and del f by del y is equal to q. This is very powerful, right? Because we know what p is. P is equal to 3 plus 2x y squared. So I'm going to erase this for a second, and let's run with that. So how do I get rid of a derivative? I integrate. So why don't I integrate all of this away by integrating with respect to x. So if I integrate with respect to x, I'm going to pick up an x here, so it's going to be 3x plus x squared y squared, right, because the y's are constant, so I'm going to keep that, and 3 becomes 3x, and if I take a derivative of this, I go back. Now here's the thing, I'm not quite done, right? So remember that if I take a derivative of this to go back to here, I have to take the derivative with respect to x. So if I'm taking the derivative with respect to x, then anything else over here that is containing y dies. So we might assume that in fact there is other stuff here that does consist of y stuff. Okay, so all this y stuff is, I'm going to summarize it by using phi y. Okay, so the function, it's a function of y. Or maybe you don't like phi, we'll call it h. Okay, so this is h of y. Something, I don't know what it is, but it's something, and it might also just be a constant. Okay, now, it's also true that if I integrate f with respect to y, del f by del y with respect to y, if I integrate that, that's going to be the same thing as integrating q, right? That's going to be the same thing as integrating q with respect to y. Now what is q? Q is 2x squared y. I'm doing it with respect to y. Okay, so this is going to be x squared, y squared, and again, I don't know what the other stuff is. It could have had other stuff with respect to x, and so I'm going to say that this is g of x. Ah, yes, so you want to ask, where the heck did these h of y's and g of x's come from? So remember that I'm trying to get rid of the partial derivative, right? So if I have del f by del y, why am I integrating with respect to y? Well, I want to get f. So this whole thing I'm claiming is f. But it's not just f, it's f which is a function of x and y. So I could write it like this, fxy, right, like that. And I can also write it right here. Now here's the thing. I have to use both of these equations to get the full picture, right? Because more knowledge is better, right, than less knowledge. So when I integrate it with respect to x, or if I integrate it with respect to y, both times I get the full function f. But the question is there anything I'm missing, right? So here I might have some other x terms. Here I might have some other y terms. So what you have to do is you have to compare these two forms of f. So here I see that there is an x squared and y squared, and here there's an x squared and a y squared. So here I have a 3x, and here I don't. But look, I have a g of x. So because g of x it is the only other thing here that contains x, and that's the only thing here other than that, which I've already matched up. That's the only other thing. It has to be that that's the g of x. So that's the g of x, right? These are equal, okay? Now, I still have this g of y, but there's nothing else it could be, so it has to be 0. So g of y is equal to 0. And what does this mean? This means that our function f of xy is equal to 3x plus x squared y plus some constant c. And the question sometimes I get is, do I have to do both? Or what if I just did this one? This is better than this one. But you don't know that it's better before you do the second one, right? You just don't know. And another thing is, it could be that both of them have something that the other doesn't have. In this case, this one is actually a better function, but it could be that they're both better than the other in the sense that they both have something the other doesn't have. In this case, it's not like that. But in any case, here is our final form, and we'll do another example in the next video. See ya.